This podcast is about learning to draw covalent structures that are a little bit more complicated than just two atoms. So just to recap the octet rule, it says that atoms will share electrons so that each will have 8. 2 for hydrogen, because it only holds 2. So we're going to walk through the 4 steps to drawing a structure for NF3. First step is to figure out which atom is going to go in the middle, and it's the one with the lower group number. So it's the one that's furthest to the left on the periodic table. If they're both in the same group, then the one that is lower on the periodic table is the one that will go in the center. Note, hydrogen can never go in the center because it only makes one bond, so it can't be in the middle. The next step is to determine the total number of valence electrons available. Nitrogen has 5, fluorine has 7, and there are 3 fluorines for a total of 26. What this means is that you have to use 26 electrons. You can't use less and you can't use more. If you have an ion, subtract 1 electron for each positive charge and add 1 electron for each negative charge of your ion. We'll see that too. Okay, the next step is to take your structure and draw a single bond between each atom. You know you're going to have at least single bonds. And then figure out how many electrons you have left. You've used up 2, 2, and 2, which is 6, 20 electrons left. And then figure out how to use those 20 electrons to spread them out so that each atom gets an octet. In the case of NF3, each fluorine is going to get 3 lone pairs, 6 electrons, and then there's 2 left over for nitrogen, which also gets 1 lone pair, and each is surrounded by 8. So the next ones, go ahead, stop the tape and work on them, and then turn it back on to check and see how you did. Okay, so a couple things. Water's pretty straightforward, it's neutral, but when you get to ClO minus, you're going to add 1 electron to your valence group for the -1 charge for a total of 14. And then when you're done with the structure, put it in brackets with a charge on the outside to show that it's a polyatomic ion. Same with ammonium, NH4+. Here we take away 1 electron, -1, to get 8 electrons because it has a positive charge. And again, put it into brackets with a plus charge on the outside to show that it's a polyatomic cation. Okay, so now we're going to draw some structures that have multiple bonds, double or triple bonds. First step is the same. Figure out what goes in the middle. In this case, for CH2O, carbon's going to go in the middle. And we've got 12 valence electrons to work with. And then put the single bonds in. And then I put lone pairs around the oxygen. You want to use a pencil so that you can erase when you do this. Hydrogen is done, so they're not going to get anything else. They can't handle more than 2. But I have used all of my 12 electrons. Oxygen has an octet, but carbon doesn't. So I'm going to move some stuff around. So I erased 1 of the lone pairs from oxygen and put them on carbon. And now carbon has an octet, but oxygen doesn't. When it feels like you don't have enough electrons, then you're going to pair up more of them and make double bonds or triple bonds. So those 2 electrons that I kept moving back and forth are making a double bond. And now carbon is surrounded by 8, 2, 4, 6, 8, 4 bonds. And oxygen, which has 2 bonds and 2 lone pairs, is also surrounded by 8. I can show that by doing the circles, and each has an octet. So try NO3-, which is the nitrate anion, and HCN, hydrogen cyanide, carbon's in the middle. Shut off your podcast and work through them and then turn it back on to check your work. Okay, for the nitrate, should have a minus over here. It's got 3 bonds to 3 oxygens. One of them has to be a double bond. It doesn't matter which one. And HCN has a triple bond between the carbon and the nitrogen has another lone pair.